Yes, Mehboob. So, can you please introduce yourself?
Sir, I'm going to BARC, the technical officer.
Okay. Yeah. Thank you. I mean, that was really important. Yeah. Please, now go ahead.
So myself, my Mehboob Sheikh. I completed my diploma from Solapur. And after that, I completed my BTech from Pune University. After that, I completed a master in technology from IIT Guwahati, including thermal engineering. And currently selected in Maharashtra State Power Generation Corporation, but still I'm waiting for the um, joining letter. I got selected.
Is it Mahajan ko?
Yes, sir.
Okay. Yeah, I'm from Maharashtra, so yeah, I'm
Yeah,
aware
yes,
of
sir.
that. Yeah. So, just as a okay. So, number one, don't tell about your Mahajan ko selection and all.
Okay, sir.
Okay.
I was means I wait to part of pass out last year. Now that's why they will ask why not you got job this
So,
time.
if they ask, then you tell, but don't tell them upfrontly.
Okay, sir.
Okay. They could definitely ask you what are you doing right now.
Okay.
So you can say that I am preparing. And next question will be, didn't I mean you have an MTech from Guwahati, so like did you opt for college placement or something like that? And then you can say that no, I don't. I just want I want to go into government only. So you can say something like that. Or you
Okay.
can then you can answer that I have already a position in Mahajanko, but it's yet everything is yet to be finalized. So you can say that.
Okay, sir.
अच्छा तुम्हारा तो बार्क में है ना. हाँ ठीक है तो
हाँ,
तुम्हारे लिए चीजें थोड़ा इजी है. इट मेक सेंस टू स्विच फ्रॉम महाजन को टू बीआरसी.
yes.
चलो बढ़िया. मैकेनिकल ना और केमिकल.
Yes, हाँ मैकेनिकल.
मैकेनिकल. ये कब निकली थी वैकेंसी मुझे भी नहीं पता. चलो अच्छा तो फिर आपने ये प्लेसमेंट नहीं ली गुवाहाटी से.
That time I was DRDO interview, so I not got selected DRDO. So that placement also gone in all that
अच्छा
person.
तो तुम वो दिसंबर में ही था जो भी था वो.
हाँ हाँ हाँ, उसी
चलो
टाइम
ठीक.
इंटरव्यू.
चलो ठीक है बट आई एम हैप्पी कि एटलीस्ट यू हैव समथिंग. लेट्स होप कि इसकी ज्वाइनिंग आ जाए बिकॉज महाराष्ट्र गवर्नमेंट इज नोटोरियसली delaying joining anything. Some of my
Yes.
friends जिन्होंने 2017 में आरटीओ का एग्जाम दिया था उनकी ज्वाइनिंग अभी आ रही है.
हाँ, again.
या एनीवे. सो महबूब yes, so why do you want to join BRC?
So BRC will give much research field oriented job. I was always interested doing in research kind of job. That's why I choose to BRC. I already tried DRDO, but I not got selected. So still I'm interested to working in research field. That's why.
Okay, never tell your failures. Okay,
Okay, sir.
you should showcase how great you are always. ठीक है, don't tell you about your failure. Then sometimes what they do is then why what happened there, what kind of question asked there, and these kind of things might just pop up. So never say anything like that. You are at BRC, so you are faithful to BRC. Okay, just say like that.
Oh,
Okay. Now can you please repeat the answer? Why BRC member?
sir, BRC will give much scope for the more scope for the research oriented job. I always have from childhood I always interested in doing research kind of job. That's why I want to join BRC.
So research kind of job could be provided by others as well. Maybe ISRO, DRDO, CSIR. So like if they call you up after on later stage, will you join them?
Now it depend on sir, but still I'm interested in BRC. It is give you much.
What do you mean by depend? Okay. Always say no, I won't go. Okay?
Oh,
What you will say?
no, I will
No,
not
I
interested.
won't go. हाँ, once I am here, I am here. ऐसा कुछ बोलना है, ठीक है?
ठीक,
वो तुमको जो करना है वो करना बाद में. But if they ask you if
ठीक.
something like that, research-based job, you can always say and always add that you were always fascinated about the nuclear energy, renewable energy. So that's why you want to join in BRC. Okay.
Okay.
Yeah. And याद रखना अगर तुम बीआरसी में जा रहे हो तो तुम ऐसा रहना कि उससे मतलब इससे मेरे को बिछड़ना ही नहीं है करके कभी जिंदगी में. ठीक है. You have to showcase that. You have to tell that. Never say कि I will think and I'll do this, do that. No. Once at BRC, always at BRC. Okay. You have to showcase that. Okay, maybe. So, what are the subjects you have command on?
Thermal fluid heat transfer is shown.
Okay, great. So, what are the different modes of heat transfer, and what are the principle behind it?
Conduct. There are normal three modes of heat transfer: conduction, convection, and radiation. Conduction happen in solid, liquid, gas also, but there is majority conduction heat transfer solid because it has more thermal conductivity as compared to liquid and gas. And convection heat transfer happen between the fluid and the solid medium, liquid medium and gases. Convection heat transfer happen between fluid and gases. Because of this dependent heat transfer coefficient. And radiation heat transfer happen in gases field where there is no other modes of heat transfer happen.
क्या बोल रहे हैं? पूरा इधर उधर कर दिया. Okay, I'll give you one more chance. And you don't need to mention this happen in solid gas. Okay, don't go too much. What are modes of heat transfer and what are the principle behind it? Don't take
Conduction,
inspiration from the last interview. Okay.
okay.
हाँ.
Conduction, convection, and radiation. Three modes of heat transfer are there.
And what are the principle behind it? Why does conduction happen? How does conduction
Conduct,
happen?
Conduction happens due to in solid flow of electrons and because of thermal conductivity, and convection heat transfer happen because of heat transfer coefficient.
ये नहीं, मतलब you are both right and wrong at the same time. Okay, what do you mean by convection happens because of convective heat transfer coefficient? ये रीजन बताओगे?
मैं
Conduction
डेफिनेशन
happens because of conductivity.
सर मुझे यार डेफिनेशन उतना तो देखा नहीं तो.
These are not even definition. These are very general things actually.
यस.
Okay, anyone else in the meeting who can tell this?
Hi, sir.
Yes, Chandrakant, please.
Uh, just there are three modes of heat transfer: conduction, convection, and radiation. And the conduction happens through in solids. It is through vibration of atoms in the lattice vibration and through exchange of they call phonon. Uh, and then in gases through vibration of let's say through kinetic molecular energy theory. Just once the gases when they interact with each other, the molecules they transfer the energy. So through that way, in gases the heat gets transferred. And the convection in the convection process, it is like bulk movement of molecules or atoms.
Mhm.
Uh, it is basically convection. And the radiation is an internal phenomena where any particular body at certain temperature emits this electromagnetic radiation. It is through probably the jumping of electrons from one layer to another.
Okay, it's due to electromagnetic radiation. You
Yeah.
don't need to go into the whole modern physics zone
Yes,
actually.
correct.
कि क्यों होता है, but yeah, electromagnetic radiation, that's a sufficient answer. Okay, महबूब, so समझ में आ गया?
यस सर.
हाँ, okay, अब आंसर कर पाओगे?
नहीं सर, वो थोड़ा बहुत देखना था क्या.
ठीक है, थोड़ा बहुत देखना चलेगा, मेक सेंस. अरे यार, ये लोग आते रहते हैं. ओके, फाइन. व्हाट इज सेकंड लॉ ऑफ थर्मोडायनेमिक्स, महबूब?
Second law of thermodynamics actually gives the feasibility of process is possible or not. First law gives the only the energy conservation principle, but does not give the idea of if the process possible or not. That's why we use second law of thermodynamics.
What is second law of thermodynamics?
Second law of thermodynamics is defined by the two statements.
Okay, now are these two statements different?
No, it is basically gives the same one, but it is one for heat engine, one is for the refrigeration.
Okay, what do you mean by entropy, महबूब?
Entropy is molecular disorder present in the system. Second law gives the process possible in entropy production means high low, there is no process possible from low entropy to high entropy. There is always be process where entropy production will happen.
You just said there is no process to go from low entropy to high entropy.
Opposite sir, high entropy to low entropy.
Okay,
A
so you
process
mean
always from.
we can never have delta S less than zero, right?
No sir, I
Okay,
mean,
great.
system plus surrounding, it is always zero or greater than zero.
Okay, great. uh, that is true. Okay, अस्मित अपना ये बंद कर देना for now. Will come later. Yes, please. Thank you. uh okay. Oh, oh, what is viscosity, महबूब?
Viscosity is when fluid is flowing, there is friction present in between the layer of fluids. It is going to, due to no slip wall boundary condition, it is reduces the velocity of the another layer of fluid. It in that viscosity. Friction,
Mm.
actually it is friction.
It is friction, yes.
Yeah.
So now, if it's friction, it will consume energy, right?
Yes.
So can you give me some example where we need viscosity
Viscosity.
or we
It
use
depends
the
on.
viscosity?
No, sir, I'm not able to remember now.
Okay, fine. Here is a question for you then. Let me open my whiteboard. Loading your whiteboard. Your caption. How can I stop it? Yes. Do I have whiteboard? Okay. So we have to. यार ये कैसा whiteboard है यार इनका? Okay, रुको मैं अपना ही ले लेता हूँ. That will be better. Uh, can you see my screen?
No, sir.
Can you see it now?
No.
No?
I think my internet low, maybe that's so.
ओके ठीक है मैं तुम्हें मे भी वर्बली बता देता हूँ वही सही रहेगा.
Sir, even we are not able to see the screen.
पता नहीं यार इनका white बोर्ड को क्या
Has
हुआ पहले तो अच्छा हुआ था. Screen sharing stopped. Okay, fine. Not issue. Okay, fine. Let it be. I'll. Okay, we have two containers. Container A, container B. Same shape, same size. Everything is same. It is made up of metal and it is filled with water.
Yes.
Okay, it is completely filled with water.
Okay.
It's a cuboid actually. You can say. Okay. And now in case A, you are hitting it from below
Mm.
using a burner, and case B, you are hitting it from above
Okay.
using a burner. Are you getting it? A
Yes.
container, in one case one it is being heated from below, in case B it is being heated from above.
Okay.
So what can you comment about the mode of heat transfer in case A and case B?
This will boiling will be happen, sir, in both
No, no,
cases.
there is
In
no boiling, it's just heating. We are not going to that high temperatures, it's just heating.
there will conduction and convection.
Yes, so case A, what will be there, case B, what will be there, that's what I'm asking.
Because the sir we hitting, then the flame will be going upside in the second case, but we don't considering the atmospheric condition.
Atmosphere कहाँ से आ गया? You don't need to think about atmosphere and all.
Okay. Sir, conduction convection heat transfer will happen in both
Huh?
cases. Conduction convection.
Yes, so case, okay, you are giving incomplete answer. Okay, which case will be conduction, which case will be convection, or both will be there in both the cases? Yeah, draw it. I'll see if I can whiteboard, new whiteboard. Okay, I think you can see it now, right?
Yes, it is coming little bit.
Yes.
Yes.
So in case A, I am hitting it from below, and in case B, I'm. Yeah, I'm hitting it from above. Okay.
Okay.
Yeah, this is case A and this is case B.
Sir, same
This
mode
is
of heat transfer will happen.
okay. Same. Which one?
This is full water is full, na sir, being both.
Yes, water is totally full, full.
Then same mode of heat transfer will happen, sir. Customer
Okay.
connection. There is no difference.
Okay. Uh, no, that is not true actually. Okay. What does a universal testing machine do, Mebo?
It is load versus deflection. You know the yield load versus deflection diagram it will give.
Correct. And how do we get a stress strain diagram then?
So we measuring the area of that specimen, and
Mm-hmm.
after if we go to the instantaneous area, we get two stress and strain diagram for that.
Correct. Now, tell me what is ductility?
It is ability of material to go in plastic deformation.
Correct. Correct. So essentially, if I ask you to draw a stress strain curve of a ductile material, how will it look? And can you draw a stress strain curve of ductile material?
A mild steel
Um,
material.
yeah, take it mild steel maybe. Yeah.
Yes.
Yeah. Can you show us, please? Correct. Now, what is the zone in which it has gone into plastic deformation?
After yield point will start the plastic deformation point.
After yield point.
Upper yield point,
And what will happen till yield point?
there is elastic deformation will happen
Correct.
in
And
up to before that.
correct. Now, whatever deformation happens after yield point, that is a permanent deformation, right?
Yes,
Let's say you take a point after yield point. You
yes,
stretch the material till that point, and then you left, you leave the load.
yes.
What will be the new length or new what will be the new dimension of your specimen? Did you understand the
Like
question?
yes, I understand. Sir, elastic deformation will regain its elastic deformation will regain, but plastic
Hmm.
deformation will present in that material. Plastic
Correct.
deformation will be
So
present.
can you draw that in a graph? How exactly will that work?
Sir, for example, you take any point, it will be the slope will be the slope will be same as the elastic slope of the starting point.
Okay, great. Correct. Okay, Mehboob. So I'll just conclude your interview now. So
Yes,
remember the points that I discussed in the beginning.
yes,
Okay.